Hey, let's take a look at this. So if you're asked to factor and you see that there's two terms um, in the polynomial expression, it might be possibly a difference of squares, or it could be a sum or difference of cubes. Now, how you recognize which one it is you basically look at the two terms. And so, for instance, if we were to look at g here, x to the 4 minus 16. So if each term in that expression is a perfect square, then you should be able to do difference of squares. And if it's a different, each term is a perfect cube, like f, x to the 6 plus 8, then you should be able to do sum or difference of cubes. Now you'll notice difference of squares. In order to factor if they're both squares, it has to have a minus sign in the middle. So this has to be a minus sign. And then what you do is basically you do your two sets of brackets and you essentially square root x to the 4, or you ask yourself, what would I multiply by to get x to the 4 if it was the same thing? So x squared times x squared gives you x to the 4. 16, square root of 16 is 4, and 4 times 4 is 16. So with the minus sign there, one should be negative, one should be positive, so that negative 4 times positive 4 gives you negative 16. Now, we're not quite done yet. Be suspicious when you still have an x squared somewhere in your expression. This could actually be factored further because that's also a difference of squares. Not this other one, though, because we have a plus sign as in between those two terms. So that one is basically finished. We can just write that one down again. But the other term can be factored again as a difference of squares. So x times x would give you x squared. And then to get to 4, you'd need a negative 2 and a positive 2. And there we go. That would be our final answer. Alrighty. Now, for sum or difference of cubes. Now, with cubes, you don't have to have a minus sign. It can be a plus or a minus sign in between the two terms. And then each term has to be a perfect cube. For instance, x to the 6 is basically x squared cubed, right? That's how you would get x to the 6. You multiply the exponents. And 8 is essentially 2 cubed. So we do have a sum of cubes here. Now, it's really just memorizing a pattern. So when you factor this, you have a binomial and then you have a trinomial, 3 terms for the second factor. And in the binomial, what we're going to do is we're going to basically cube root each expression, or each term of that expression. So x to the 6, the cube root of that is x squared, and 8, the cube root is 2. And the sign that goes in between is the same sign from the original expression. All right, so there's the binomial. Now, to get the trinomial, to get the first term, you square the first term from the binomial. So it'd be x squared squared, so x to the 4. You do that as well for the last term to get the last term in the trinomial. So you square that as well, and the square of 2 would be 4. Always a plus sign because you're squaring it. And the middle term is basically the two terms multiplied together. So x squared times 2, and you use the opposite sign. So you would go minus 2x squared. And there we go. That would be your factored form to do a sum or difference of cubes. Alrighty, there we go. So when you see two terms, could be a difference of squares, or it could be a sum or a difference of cubes. Alrighty, I hope that helped.